So let's talk a bit about significant figures. We're going to talk about which digits are significant and which aren't. But first, I want to talk a little bit about why we even need significant figures in the first place. The reason we use the significant figures convention is because we don't want to write numbers that imply a precision that we don't really have. Okay? If I use a regular ruler like this one, okay, it is broken out into millimeters. I don't want you to think that I really know any further than down to a single millimeter what this length is. I can't measure it in between those, okay? So I need to write a number with whatever unit that indicates that I have a precision down to a millimeter. And even when I continue to do math with that, I need to figure out how I'm going to write those numbers so that they have the right precision. And anybody who's gone to a calculator and typed in 1 divided by 3 can see that you could wind up with a number that just goes on and on and on forever when you do some math. But you can't use all of those digits because you don't know down to that level of precision whether or not the value should be correct. You only know to a certain number of digits, and we need to reflect that when we write it. We could do that a lot of different ways, and really part of the whole thing with the significant figures is we're trying to encode it in the way that we write the number. It's really kind of lazy. We could add more information in there so that you knew the level of precision, but we don't want to do that. We want to look just at the number and be able to tell how much precision we have. So there are a couple of rules, and most of them revolve around what we do with the zeros, because those are usually the confusing ones. So that's kind of reflected in our first rule here. So we have all non-zero digits are significant. So anytime you write a 1 through 9, those are all significant. Okay? It's only whether or not these zeros are significant. So the next one we have is that all zeros between any two non-zero digits are significant. These are called captive zeros. So if I have a 3 here and a 7 here, these are both non-zero digits. This 0 in the middle is significant. Our next rule is that all zeros to the right of a decimal point and left of a non-zero digit are not significant. Okay, so we have this leading 0 before the decimal place. Now we only place that there just to make it clear that there's a decimal place here. That's the only reason that this convention ever started, and you could easily write this without that 0. So this 0 is never significant. None of these leading zeros are going to be significant. And then we have our decimal place, and then we have a couple of zeros, and then we have some couple non-zero digits. So these ones here, between the decimal place and our first non-zero digit, these are not significant, okay? And you can kind of think that you have to have these zeros here just to make this number correct, right? So these are just placeholders, right? So they don't have any significance. Now that brings us to the next thing we have. So the zeros to the right of the decimal point without non-zero digits following them are significant. So what we're saying here is that if we had a number like this, we got a decimal place, we put these zeros in, these ones all of a sudden are significant. And you could think, I could have just written 20, right? But I went an extra step to put that decimal place in and put these zeros in here. So they're not essential to just writing this number out. So the only reason I would do that is that I knew that these values were 0, and that's what causes them to be significant. Our fifth rule are that all zeros to the right of a non-zero digit and decimal point are significant. Okay? So if I have a number like this, we have this leading 0, that's not significant. We have these here, they're not significant. Okay? But then we write out some numbers, and again, these last zeros, well, those are significant. I didn't need them to write this number out. and for it to be correct, I added them at the end because I knew that those were zeros. And the final one involves when we don't have a decimal. So if we have trailing zeros that are not significant without a decimal place. So if I write the number 1030, 1030, this last zero is not significant. Now if I want to write this such a way that this number is significant, well, I'm going to do something kind of weird here now. I'm going to write 1030. I'm going to put just a decimal place there. I'm not going to add another zero after it or anything. And now I've indicated with my decimal place that this last zero is in fact significant. Now calculating with sigfigs. Okay, so we have two different cases here. We have the case where we're adding and subtracting, and a case where we're multiplying and dividing. Okay, so when I'm adding or subtracting, what I'm going to do is I'm going to line up the decimal place all the way down here. Okay, and then I'm going to go up here and I'm going to look at these places and I'm going to go to the one that has the fewest number of places. So this one has an extra one, this one has an extra one, 2 here, but this one's only out to the hundredths place. So that's the lowest one, and I'm going to just imagine I draw a little line right down there. Okay, and then I'm just going to add them together like I normally would, carrying the one and going along until I get my final number. Okay, now what we're going to do is we're going to round it. We're going to get rid of this part over here and we're going to round it to this value right here. And we're going to go with our typical rule where if we have a 3, a 5, or if we have less than a 5 here, we're going to round down. If we have a 5 or greater, we're going to round it up. So 3 is less than 5. We need to round this down, and our number is going to be 65.09. Okay, so multiplication and division, what we're going to do is we only get as many as the number that has the least number of significant figures. So here, this number, 12.37, that has 4 significant figures. We're going to multiply that by 7.23. That has 3 significant figures. We do the multiplication out. We get this value here. And now we need to round this down to 3 significant figures, because this is our limiting one. This has the fewest number of significant figures. And we'll go ahead and follow our rule to round down from 3. And we get 89.4. And we have a number that has 3 sig figs.